In this video, I will be talking about angles and degree measure and 12-2 trigonometric functions and acute angles. So in angles and degree measure, we know from the circle, one complete circle is called one revolution. And this is also equivalent to or congruent to 360 degree measure. So you can think about it as half a revolution is going to be 180 degrees, where quarter of the revolution is going to be 90 degrees, 1/8 of the revolution is going to be 45 degrees. And 360 degrees and 720 degrees, which is double 360, ends at the same spot. So one rotation, one revolution ends at where you originally started with. Or if you rotate one extra time, then you end at the same rotation. So here, data and data plus 360 degrees will be considered as the same angle because it shows you the same location. As an example, 45 degrees, then it's going to be half of 90. So let's say this is where you started, then we call this a initial side. Then if you go up by 45 counterclockwise, then the angle it forms is 45 degrees, and where it ends is called terminal side. Then here this 45 degrees is equal to 360 plus 45, which is 405 degrees. So 405 degrees is congruent to 45 degrees in terms of the initial side and the terminal side. Another thing that you may learn from 12-1 is the usage of degrees, minutes, and seconds. That we all know 1 minute is equal to 60 seconds. That applies the same logic here, that 1 degree is equal to 60 minutes, and that is also equal to 3,600 seconds, where 1 minute is equal to 60 seconds. So you can possibly convert 1 degree, 15 minutes, and let's say 30 seconds. You can convert it back to all in terms of degrees only. So this is equivalent to 1 degree and 15.5 minutes, and you convert the minute back to degree by 1 degree times, or 1 degree plus 15.5 times, or 15.5 minutes times 60 minutes of 1 degree. Then if you simplify it, you'll be getting 1.2 something degree. Pretty simple. Then you shall pause the video here and try all problems in 12-1, including mixed review exercises. And here we shall move on to 12-2, and 12-2 talks about trigonometric functions of acute angles. The basic trigs, cofunction identities, and Pythagorean identity. So you will see the term sine, cosine, tangent, secant, cosecant, and cotangent. These are the basic trigonometric functions where they all represent the ratio of acute triangle sides. So when you're given a triangle, then you must think about an angle of the triangle. Then always we consider the triangle to be a right triangle. So you must have a right angle right here. Then there will always be the longest side. Then we call the longest side hypotenuse. Then from the angle that is being formed, there are two adjacent sides, but because the longer adjacent side is called hypotenuse, the shorter adjacent side we call it adjacent. And the one isolated side that is on the opposite side of the angle is called opposite. So sine of an angle is always going to be opposite over hypotenuse, or cosecant of an angle is always going to be hypotenuse over opposite. Cosine of an angle is adjacent over hypotenuse, and secant of the angle is hypotenuse over adjacent. So you probably have an idea that cosecant of theta is equal to 1 over sine of theta, and secant of theta is 1 over cosine of theta. Tangent of theta is opposite over adjacent, and cotangent of theta is adjacent over opposite. So giving you an example, let's say you're given a triangle that has 3, 4, and 5, and this is going to be angle 1, and I'm going to call that angle 2. Sine of angle 1 is going to be 4 over 5, since the opposite of angle 1 is 4, and the hypotenuse of angle 1 is 5. Or cosine of angle 2 is going to be also 4 over 5, since from the view of angle 2, 4 is adjacent and 5 is still hypotenuse. You can probably be able to figure out the rest of the 6 or 5 other trigs, and from this we can build up two identities. One is cofunction identity and the other one is Pythagorean identity. That sine of an angle 1 is equal to cosine of an angle 2 if angle 1 plus angle 2 makes 90 degrees. As an example, sine of 2 degrees is equal to cosine of x, where x is going to be 88 degrees. And how this works, 2 plus x must make 90, so that sine and cosine are equal. So x has to be 88 degrees. And another very popular identity from trig is that sine of any angle squared plus cosine of any angle squared will always be 1, and we can abbreviate it as sine squared theta plus cosine squared theta is equal to 1, where theta can be any angle. So you can plug in theta as 2, then it will make sense. You can plug in theta as 15, then it will make sense, and any angle can work. And now lastly, usage of the calculator. So in this problem, you must have a graphing or scientific or graphing calculator, but let's say sine of an angle is equal to 0.7. That's given to you, then you know that 0.7 has to be opposite over hypotenuse by the definition of sine, because sine means opposite over hypotenuse. So this gives you that when you have a right triangle and given this is the angle that we're aiming for, opposite length is going to be 0.7x and hypotenuse is going to be, no, not adjacent, hypotenuse is going to be 1x. Therefore, that's 0.7x over 1x. X cancels each other, you get 0.7. We do not know the x yet, but from this, let's say I gave you, oh, actually the adjacent side is equal to 10. Then what you can do here, knowing this is equal to 10, you can use Pythagorean identity. So set up, or you can use, Pythagorean identity that a squared plus b squared is equal to c squared. So 100 plus 0.7x squared is equal to 1x squared, and solve for x, and then you'll be able to solve the problem. And you can pause the video here and try all problems in 12-2 and also including mixed review exercises.